Hi team, Dave Domenic, training manager here at Amplify Surgical. The following video is the most commonly sought for tips and tricks with regard to the dualX system. When using the path clearing tool, make sure that the laser mark seats all the way down to the shoulder. If it doesn't, perhaps the tube assembly is caught on a tube or pushed by a retractor and the path to the implant is not collinear. Make sure you toggle the tube assembly in order to get that laser mark seated and therefore be collinear, getting ready to deliver that screw. It's helpful to check a lateral fluoro image to make sure that the tube assembly is collinear with the implant, like so. If for some reason the lockout screw is having trouble tracking, use the thread clearing tool, or the drawbar will work as well. The thread clearing tool has a nose that mimics that of the screw and can oftentimes clear debris out of the nose of the implant and rethread the implant. If you get resistance, turn through it and make sure that that most distal line goes down to the shoulder, and then turn counterclockwise and unthread it just like you did to deploy it. Then try the screw. It doesn't happen very often, but if you deploy the lockout screw and the black torque limiting handle torques out prior to the black line engaging the shoulder, there may be debris caught in the threads of the nose, or it could be cross-threaded. In order to remedy this, you can do a couple of things. First of all, switch from the torque limiting handle to the fixed handle, the blue. You can try to overcome whatever debris or cross-threading issues you have by using the fixed handle, and just try to overpower the threads and kind of white knuckle it until the black line reaches the shoulder. Again, the blue handle won't torque out, but it will provide power to drive the screw down if the torque limiting handle cannot. The next remedy would be to remove the screw and use the thread clearing tool to remove any debris, reform the threads, and make sure you're collinear with the tube assembly into the implant. You can really crank down on this thread clearing tool and try to overpower whatever debris is in there. Then you would go back with the screw on either the black or the blue handle and really be able to crank it down. If all else fails, reattach the handle, collapse the implant slightly, and then re-expand it fully and repeat the process. When expanding the implant, make sure to turn the handle to where the drawbar shows silver below the vertical line. Go past the line. That ensures that the implant will be fully expanded and therefore will have enough space to accept a lockout screw to go across the space. If the implant's not fully expanded, there's a possibility that the lockout screw won't reach. So we want to make sure that it's fully expanded, like so. If for some reason the appropriate screw still won't go across, a T-lift screw can be used. Please note this is off-label and will protrude out the nose approximately 4 millimeters. So make sure you have enough room anteriorly to accept the nose of that screw. The cage guide can be used in two orientations. The handle laterally to be used as a nerve root retractor, or the handle medially to be used to protect the dura, and then the cage is inserted down the slot. Be sure to insert the full 25 millimeters of beveled tip into the disc space when inserting the cage guide. And then make sure to remove the cage guide as the implant goes in to make sure that the cage guide doesn't get stuck. If for some reason you've detached the tube assembly, delivered the screw, and the surgeon wants to go back and reattach, perhaps to reposition, here's the technique. Take the screwdriver, attach it to the screw under direct vision. You'll hear it click in place. Put the tube assembly over the screwdriver and engage down to the implant where there's no space here, and tighten this hex finger tight. Don't use the funnel as it goes on too tight and then can't be removed later with the thumb wheel. Now put the screwdriver on the handle and remove the screw. And then put the handle back on the tube assembly. You'll notice that the threads of the bolt are protruding out past the strike plate. Leave those as is. Put the drawbar in from behind, and instead of doing the two-step process, skip directly to step 2 and plunge and turn until tight. You'll notice that the drawbar did not engage the nose. It's very hard to do so once the implant is in the disc space. Now, once you turn the handle counterclockwise, watch as the drawbar self-aligns with the implant and collapses. Now you'll have to remove the entire assembly, go back to the back table, and prepare it properly as you did before the first implantation. For those who have been around dualX for some time, you'll know that we've had several different methods of bone grafting. Pre-packing the disc space is acceptable if it's limited. We don't want to crowd that disc space up too much, as this implant is going to double in width. So limit pre-pack. As far as post-packing is concerned, there's a couple of different ways. The first way is to deliver bone graft prior to delivering the lockout screw. And the method for that is a couple of different ways. The first way is to keep the tube assembly attached to the implant, put the funnel on the inner tube, and put bone graft and deploy it while this tube is still attached to the implant. This becomes quite tedious and time-consuming. The other way to go about doing that is to have a tube full of bone graft loaded on the back table, and then we'll do a swap technique. And it goes as follows. So we have the tube assembly attached to the implant. Remove that inner tube, but maintain the orientation and stay docked with the outer tube. We'll replace the inner tube with one filled with bone graft. As long as I stay docked, the inner tube should still be able to be engaged, and then we'll take the bone tamp and fill with bone graft. That's called the swap technique. The important part here is to stay docked with the outer tube. Now that you have bone graft in the implant, we need to create a path through that. The path clearing tool does a very good job of clearing a path to the nose of the implant as long as you go down to the laser mark. The next step is to clear the threads with the thread clearing tool. We want to make sure that we engage clockwise down to the most distal line. The other lines are for our lateral procedure. If you get resistance here, turn through it as you are actually clearing debris, bone graft debris, from the threads, and then remove it counterclockwise. before deploying the screw. The other method of bone grafting is to do so after the screw is delivered. So we would remove the handle from the tube assembly. We would take the path clearing tool and just make sure that our tube assembly is collinear with the implant and the threads of the nose. If not, the laser mark will stop short of the shoulder. Toggle the tube assembly until you're collinear. You can also check a lateral fluoro to make sure that this tube assembly is collinear. And then maintain this orientation once that laser mark seats into the shoulder. Maintain the orientation with the tube. Come straight out with the path clearing tool and go straight in with the screw. Go down to that same line and the screwdriver will torque out. Come straight out with the screwdriver handle and use the funnel as a wrench to remove the tube assembly. Turn counterclockwise on the inner tube. Both tubes will come off. Now we have a tube with a nozzle tip on it loaded with bone graft. It'll take about 5 cc's of something flowable. And the nozzle tip seats just above or below that lockout screw in a recess. It doesn't affix, it just sits and delivers bone graft with the bone tamp. The limitation of doing bone grafting this way is the aperture of the nozzle tip. So we need something flowable, some kind of DBM putty, something that comes in a syringe. If for some reason that's not available, do the following. Load the tube as we've said before and remove the nozzle tip. Put the tube assembly just over the screw and into the aperture or the recess of the implant and use the bone graft tamp to force the bone graft into the implant.